Hey guys, Chavez here. Let's read on this vertical asymptotes and holes. So let's read example 11 and conclude what it's trying to say. All right, so it says, let's start by looking at a very specific function. Let's look at f of x equals x squared minus 1 in the numerator over x minus 1 in the denominator. Something special is happening at x equals 1. Is it a vertical asymptote? Is it a hole? Okay, so at x equals 1, guys, this is undefined. That's because you get a 0 in the denominator. You also get a 0 in the numerator as well. That's called indeterminate form. But for now, that's not necessarily important. Know that this function is not defined at x equals 1 because you get a 0 in the denominator and you can't divide by 0, guys. So we left with these two options. Which one is it? Is it a vertical asymptote or is it a hole? So let's see what this example, well, I wrote this example. Let's see if I do a good job explaining, and then I'll go ahead and give you guys more detail. Hopefully you notice that the numerator is a difference in squares, so we can expand this function, and now we have f of x equals x plus 1 times x minus 1 over x minus 1. And we observe that the numerator and denominator have the same binomial. Okay, I didn't say that correctly. The numerator has x plus 1, x minus 1. That's, binomial just means two terms. So I have an x minus 1 in the numerator, and I have an x minus 1 in the denominator. So that's what I mean. I have the same factor. We can cancel this binomial and reduce the equation to f of x equals x plus 1. That's because I can cancel these factors out like that, see? But there's a problem. Our original function is not x plus 1. So what exactly is the math telling us? It is telling us that f of x behaves like x plus 1 in the entire domain of f of x. Basically behaves exactly like x plus 1 everywhere except at x equals 1, where f of x is undefined. Okay, so all that means, guys, when you cancel your factor, your x minus 1 factor, you have this x plus 1 factor. So that means this function, x squared minus 1 over x minus 1, behaves like x plus 1 everywhere except at x equals 1, because you're not defined at x equals 1. Remember that. So what do you have whenever you have a factor that cancels out in the numerator and denominator, this binomial here? You have a hole. See? Hole at x equals 1. And then how do you find the y value of the hole? You just plug in, see it. I'm sure I say that. So in conclusion, we have a hole. Okay, it doesn't tell you that. So how do you find the y value of that hole? You plug in that 1 value into whatever you have left. You have x plus 1 left. And 1 plus 1 gives you that 2. And that's how we get the hole of x equals 1, y equals 2. So in conclusion, I did it here. So in conclusion, if you set the denominator equal to 0 and solve for x, that's usually the vertical asymptote, unless the expression in the denominator cancels an expression in the numerator, in which case you have a hole. Regardless of the situation, regarding rational expressions, the function is never defined for x values that make the denominator equal to 0. All right, so here we go, guys. So in conclusion, I'm just going to go ahead and use letters in the alphabet. So if you have something like this, so I'm going to write x minus a, x minus b, x minus c, all over x minus, I'm going to go ahead and write c, and then I'm going to go write x minus d. So what does that mean? So here you go, guys. I have a rational function. I have a polynomial, a cubic in the numerator and a quadratic in the denominator. When you expand this, you'll have an x cubed. When you expand the denominator, you'll have an x squared. So notice that I have an x minus c here and an x minus c here. So those are going to cancel out. So because they cancel, you're going to have a hole at x equals c. Now, you see how this x minus d here does not cancel out? So that x minus d, that means, since I don't have a factor in the numerator that's x minus d, that means I have a vertical asymptote. Vertical asymptote at x equals d. So there it is, guys. So if you can cancel something out, then you're going to have a hole. And if you can't cancel something out, whatever makes the denominator undefined, you're going to have a vertical asymptote. So let's see if we can work on a few. So let's do number 29, just to get you guys started, and then hopefully you guys can take care of the rest here. Remember, guys, to find your x-intercept, set the y value equal to 0, because whenever you cross the x-axis, the y value is 0. So just set that equal to 0 and then solve. So maybe make sure you cancel any factors out, right? Because if it's possible to have a hole on the x-axis. So be careful there on that. All right, so question 29 says, give the vertical asymptotes for this graph. All right, first thing you got to do, guys, is you got to expand this, and you got to make sure, so you got to find your factors, right, if it's factorable. So I have, let's see, so I have negative 16 here, so I need to figure out two numbers that multiply to give you negative 16, but add up to a positive 6. So usually they'll just say something like this, right? They'll write like negative 16 over here, and then what do they do? Positive 6 over here. So they'll say, okay, give me two numbers that multiply to give you negative 16, but a positive 6. Well, let's see, 8 and 2, right? 8 and 2, 8 times 2 is 16, and then the difference of 8 and 2 is 6. So positive 8, negative 2, because you got to have a negative 16, right? So I'm going to write x plus 8, x minus 2. So that goes in the numerator, and on the denominator, you're going to say two numbers that give you negative 63, but when you add up to a positive 2. So then you start thinking like, okay, well, what numbers give me 63? And hopefully you remember one of them is like 9 times 7. And yeah, let's see. 9 times 7. Yeah, 9 times 7 is 63, and the difference of 9 and 7 is 2. So x plus 9, x minus 7, because I need to have a negative 63, but I got to add up to a positive 2. So there it is, 9 and 7, guys. Nothing cancels out. Notice I don't have a factor that cancels out. So it wants to know where are my vertical asymptotes. Well, my vertical asymptotes is wherever makes my denominator 0. So denominator is going to be 0 at x equals negative 9. Negative 9 plus 9 is 0, and at x equals 7. There it is. Nothing canceled out, so I don't have any holes. So those two must be vertical asymptotes, negative 9 and 7. Then you got to insert the x value, guys, because if you don't tell me x equals, then then you're not telling me where my vertical asymptote is. Remember that x equals negative 9. That literally is a vertical line. So there it is, guys. I hope that you guys have enough knowledge now to tackle these out. Remember, factor out this negative here in the front first for question 32. So factor it out, guys, and whatever cancels out, that's going to be your where you're going to have a hole, right? There's a common factor that cancels out. So yeah, let me know, guys, if we still have issues with that, and yeah, keep me in the loop. All right, bye.